Welcome to this video on documenting your data science code. In data science, clear and well-documented code is just as important as the code itself. Documentation makes your code readable, helps you collaborate with others, makes your projects maintainable, and ensures your results are reproducible. Let's dive in. Data science is rarely a solo effort. You'll be working with teams, sharing code, and building on each other's work. Reproducibility is crucial for validating your findings. Others need to be able to understand and rerun your code to confirm your results. When things go wrong, and they will, good documentation makes debugging much easier. You'll be able to quickly understand the code's logic and identify the source of the problem. Think of documentation as a gift to your future self and your colleagues. It saves time, reduces frustration, and ultimately leads to better data science. Before we dive into the details, let's start with a basic but vital element, the code header. A code header is a block of comments at the very beginning of your file that provides essential information about the code. At a minimum, a header should include the author's name, the date the code was created or last modified, and a brief description of what the script does. This quickly orients anyone opening the file. Optionally, you can also include a license, which specifies how others are allowed to use your code. This is especially important if you plan to share your code publicly. Adding a header is a simple but important practice that helps give credit to the author, provides context, and can even help with version control in larger projects. Now let's move on to docstrings. Docstrings are the primary way to document your Python code. They are multi-line strings enclosed in triple quotes that describe what a function, class, or module does. For simple functions, a single-line docstring might be enough. It should briefly explain the function's purpose. For more complex functions, use a multi-line docstring. This allows you to provide more detailed information, including arguments, return values, and any exceptions that might be raised. A popular and highly readable format is the Google-style docstring. It uses a consistent structure with sections for args, returns, and other relevant information. It's a great standard to adopt. Notice the type hints in the Google-style example. We'll talk more about those later, but they add another layer of clarity to your documentation and can help catch errors. Comments are short explanations within your code that are ignored by the Python interpreter. They're used to clarify complex logic, explain tricky algorithms, or provide context where the code itself isn't enough. However, not all comments are helpful. Avoid comments that simply state the obvious. For example, multiply width and height doesn't add any value. The code already shows that. Instead, focus on explaining why you're doing something or any assumptions you're making. For example, calculate the area of a rectangle. This function assumes width and height are in the same units. This explains a potential limitation. Remember to keep your comments up to date. Outdated comments can be even more confusing than no comments at all. Regularly review and revise them as your code evolves. Type hints are a powerful way to specify the expected data types of function arguments and return values. They make your code more self-documenting and help prevent errors. Without type hints, it's not always clear what kind of data a function expects or returns. This can lead to confusion, especially when working with complex data structures. With type hints, you can explicitly specify the data types. For example, data. List of dictionaries indicates that the data argument should be a list of dictionaries. This makes the code's intent much clearer. Type hints improve readability, enable static analysis tools to catch type errors before runtime, and provide better support for code completion in IDEs. Let's put it all together with a practical example. Here's a simple function that calculates the mean and standard deviation of each column in a data frame, but it's completely undocumented. First, we'll start by adding a proper header with the author, date, and a brief description of the script's purpose. Next, we'll add a comprehensive docstring, explaining what the function does, detailing each argument it expects, and clearly specifying what it returns. Finally, we'll add type hints to ensure that the data argument is explicitly defined as a pandas data frame, and that the return value is a tuple containing two pandas series. By adding a header, docstrings, and type hints, we've transformed this function into a well-documented, easily understandable, and maintainable piece of code. Anyone who reads it will immediately grasp its purpose and how to use it correctly. For larger projects and more complex documentation needs, consider using a dedicated documentation generator. Sphinx is one such documentation generator, which can automatically create beautiful and organized documentation from your docstrings. And remember to adhere to a consistent style guide like PEP 8. PEP 8 provides valuable guidelines for formatting your Python code, including recommendations for writing docstrings and comments, promoting code consistency and readability. Mastering code documentation is an essential skill for every aspiring data scientist. It's not just about writing code, it's about writing understandable code that you and others can use and maintain effectively. So, start practicing documenting your code today. Begin with small steps like adding headers and docstrings, and please share your best documentation tips and techniques in the comments below. Let's learn together.